Hello YouTube! In this video series I will be showing you some embedded electronics. We will write code to STM microcontrollers, to me the most powerful and convenient microcontrollers in the world. Anyways, make sure you watch all my videos and subscribe my channel to encourage me to create more videos like that. If you want to ask anything, feel free to drop a question down below to the comment section. I will try to answer all. Today we will set timers on the MCU in STM32F429i Disco Evolution board using CubeMX and HAL library. We will write very brief code and set timers, one in Timebase and one in PWM generation mode. We will end up PWM modulated signal. We will check that via scope. We will start our project from CubeMX code generation program. STM MCU units come with numerous advanced peripherals like Ethernet, USB, LCD controllers unit, and so on. Adjusting these all can be very problematic, although we won't use them in our projects. Thanks ST for creating CubeMX, making our life easier. Basically, CubeMX does all nightmare initialization settings behalf of us, and the only thing we have to do is to tell it which peripherals we want to use in which settings. In this project, we will use timer 2 for PWM generation. We need to set channel 1 for PWM generation. As you may see, GPIO PA5 automatically set to alternate function timer 2 channel 1. We need to select internal clock as clock source. In configuration window, as you see, there are a set of tabs. NVIC stands for Nested Vector Interrupt Controller, which is nothing but a bunch of registers. We need to tick this box to enable interrupts of timer 2. In some project, you may need to fetch data request or storage to your MCU. If you use DMA, you will not lose any incoming data, or you will be able to supply continuous data to your peripheral while your main CPU doing other processes, which is not our case. User constant stop is to generate some variables in auto-generated code. Parameter setting stop contains clock prescaler adjustment and initial values of timer registers. To fill these values, we need to check our clock configuration. Clock settings in CubeMX couldn't be easier than this. This tab shows all clock mapping in MCU. The only thing to do is checking which clock source is going to your peripheral and what value of frequency. In this pop-up window, CubeMX indicates me some error. If I click yes, it will correct all false prescaler and multiplication factors. In this case, our peripheral is connected to AHPB1 peripheral block, and 72 MHz is supplied by our internal clock to this peripheral block. I want to divide this frequency to 72 by adjusting prescaler value to 72. You may find all extensive information in reference document. As you see, I set the period to 1000. Our counter will count up to 1000 and roll back to 1 again. By doing this, our timer will generate 1 kHz PWM signal. Now we need to tell CubeMX which directory our project will be stored. We need to specify our IDE. In this case, I will be using KL MDK v5. In other tabs, you may see other code generator options. Now we can generate our project. By clicking Generate Code, CubeMX will create a project file. We'll do all settings, create scripts files, and store them properly in the project according to general coding standards. In this tree view, we can see all library files and application-specific files. CubeMX also created a main file for us. It also created some handle type devs to adjust our selected peripherals, timer 2 and timer 3, as well as init functions. We need to compile our project in order to use go-to-definition command. As you may see, CubeMX generated project is ready to compile and program our device without any modification. The only thing we need to do is writing a PWM start command. Now we can compile our project and check if we see PWM signal in pin PA5. I have entered 500 to pulse value in CubeMX. Basically, timer 2 counter counts up to 1000 and rolls back again to 1 value. In PWM generation mode, output pin becomes active state when catch and compare register value higher than counter value, and vice versa. Thus, we generate 1 kHz 50% duty PWM signal. Now we will use timer 3 as Timebase to change pulse width value by time. We need to select internal clock as clock source. Timer 2 and timer 3 are on same peripheral block, so they both are going to supply it by 72 MHz. We will adjust 72 for prescaler value and 10 for counter period. We need to click timer 3 global interrupt enable checkbox in MVIC settings tab in configuration window. Now CubeMX is ready to add new peripheral to our project by clicking Generate Code. By clicking Yes here, we will accept externally changed files in our project by CubeMX code generator. Just like timer 2 PWM generation mode, we need to write a start command for timer 3 Timebase mode. Now I will show you a very cool feature of STM microcontrollers and KL IDE. After programming the evaluation board, by clicking the debug button, we will check whether the time-based interrupt works in real time. Basically, I inserted a breakpoint in interrupt callback function. In this drop-down list, I can select a peripheral and see the registers of it in real time. By clicking Run, we have to see our program enters a breakpoint that I already inserted the callback function in timer 3 time-based interrupt. As you can see, it enters the callback function and stops in the breakpoint I inserted. Now we will write a brief code here to change the duty cycle of timer 2 PWM generation. One thing to take into consideration while working with code generators. You need to write your own code given places. Otherwise, your code will be vanish after regenerating project. We will define two variables here. One is to increase and decrease duty cycle, and one is to store direction data. We will write a code here in timer3 interrupt callback function to increase duty cycle up to 1000, which is 100% duty, and then decrease down to 1, which is 0% duty. Now we need to write a command here to change the catch and compare register of timer 2. Now we can compile our project and program our evolution bot. As you notice, the change of duty cycle is faster than we can see. We will basically increase timer 3 Timebase period and compile our project and upload again. Thank you for watching. I hope you enjoyed. To encourage me to create more videos like that, please subscribe my channel. If you want to ask anything, feel free to drop a question down below to comment section.